Welcome to the Internet Report, where we uncover what's working and what's breaking on the internet and why. Today I'm joined by Mike Hicks, who's Principal Solutions Analyst here at ThousandEyes, and we have two really interesting application outages that we're going to talk about. So really excited that he's able to join us today. So welcome, Mike.
Right, thanks, Angelique. It's always a pleasure to be here.
Yeah, so the two outages that we're going to cover today didn't happen last week. They actually happened a couple weeks back. So one of them happened on May 19th and the other one on May 20th. And both of them are very well-known applications. One of them has sort of a financial impact, and the other is very tied into how many businesses communicate today.
Yes.
We had an issue with Bitcoin, or rather an issue with Coinbase, who is sort of a Bitcoin broker, and Slack.
Yeah, absolutely. Yeah, I mean, one of the important things is, we're always talking about the end-to-end and the network. This is a combination of the application relying on that underlying network infrastructure and what can go wrong.
Yeah, for sure. So oftentimes some of the outages that we cover, they have either a network component or maybe a routing, internet routing issue that might then impact the network. In these particular instances, we're going to look at what we were able to see at the application layer that gives us some clues that align to what we now know was the issues that caused some of these incidents. So we're going to start first with the Coinbase outage. So we're going to walk through that. This particular incident occurred on May 19th, and it started fairly early in the morning. So it was 12:50 UTC, and that is 5:50 a.m. Pacific time and 8:50 a.m. On the East Coast. And so this basically happened as many people were waking up to the news that the Chinese government had cracked down on Bitcoin or the usage of Bitcoin by banks in China.
Yeah, that's correct. So there was several outside influences, I guess. As you said, the Chinese currency, the Chinese government decided to some crackdown on all cryptocurrencies. It wasn't specific to Bitcoin. It was just stopped using those areas there. And then there was other organisations who actually had made decisions to stop accepting Bitcoin, in particular for their in return for some of their products. So all this stuff sort of built up.
Right, and Coinbase is a very well-known Bitcoin brokerage or cryptocurrency brokerage company, and so in order to for a lot of people, the way that they access their Bitcoin and the way that they transact on it is through this brokerage. And so what we can see here is that beginning at around 8:50 Eastern time, we can start to see a dip in availability. And we can also see, as it starts, that we start to see timeouts. So basically the, users around the globe trying to connect to Coinbase's site are getting, it's taking a long time for them to get responses. In this case, it was over 5 seconds, and at that point, they're still not able to get a response. So clearly indicates that there's something that's not quite right happening at the application. And then a little bit further along, we can see things like 502 bad gateway, sort of indicating that the server that we're connecting to is not able to reach the application on the back end.
Yeah, exactly. I think I think it's important to point out there. What we're looking at here is we're actually looking at the application of the Coinbase stuff. There's a number of things going on in the back end, which we're going to get to. But what we're saying here is that people actually can't get on to do trades at this time. So the service and the application stuff becomes unavailable.
Right, and we see several different types of issues. So in one instance, we see here we're just getting a timeout. We have a particular threshold of 5 seconds set. And it's clearly taking longer than that. And then we're also seeing 502 bad gateway, but we're also seeing 429 too many requests, again, sort of indicating that there's probably too much load on the application in order for it to fulfill requests. So it's not even able to serve up the home page for Coinbase, let alone process transactions. And so this is pretty significant in terms of throughout this period, there's, it's somewhat intermittent, but for the most part, we see that most users would not have been able to connect to Coinbase and probably would have had issues logging in. And once they, even if they were able to successfully log in, they probably wouldn't have been able to make trades at that point.
That's correct. Yeah, they'd have sat in a pending state. So they've gone through their process, they'd load up the application, and then when they started to do something, it would have sat there and just returned this message: your trade is pending.
Right, right. So it's, here at this point in time, we're basically at like the 4-hour mark in terms of how long the issue has persisted. So basically, we don't start to see a normalization in terms of availability until basically 4 hours later, which is pretty significant if you are suddenly realizing that the value of Bitcoin is starting to plunge and you want to maybe get in and execute your transactions, and you're simply not able to do that because the service that you're using is unavailable. And just to kind of reinforce the application related nature of this, if we look, for example, at the network paths to the application servers, we can see that everything looks good here. There's no outsized packet loss. And we can see that the front end of this application is being served by Cloudflare. So it's a CDN provider. They have a lot of servers that are located around the globe, and that all looked fine. They were able to reach the servers, but it seems like the application wasn't responding. And so because of that, we're seeing those errors. Yeah.
Exactly. There's a couple of things in there. So the first one is that the network tells us an incredible story about what's happening at an application level. It is the biggest part of the journey that you're going to go through. So, but at the same time, then the fact then that we're actually having messages come back from the server. So those 500 errors, those 429s are responses from the server to a transaction or a request coming in there. So, we're able to tell so many things by looking at this network traffic. I guess that's the point I want to make there.
Right. Yeah, that's a really good point, because not only do we see from a network standpoint, everything looked fine, you can reach the server. And of course, we know you can reach the server because you're getting a response from the server. If you weren't able to get there, it wouldn't, that wouldn't have been possible. So, the application is responding in some fashion. Now, what's sort of interesting about this in terms of, the severe nature of it, the prolonged nature of it, the impact that it had, again, like if you're not able to do something with a financial service that's like 4 hours, that's pretty significant. But why would Coinbase not be able to keep up with the increased load? There's a lot of applications where, they might be able to sort of elastically, kind of scale in order to meet, this new demand, but that didn't seem to be the case with Coinbase.
Yeah, absolutely. This is a great question. There's a couple of things that occurred here on the outside. So first of all, we talked about this outside influence, and the point you pulled out there about the 4 hours, things can happen dramatically. So what we saw here was a plunge based on the information that we'd see there. The price dropped dramatically within that first hour of trading. So this is when people are trying to get on. There's also a whole bunch of automatic sell positions which would be triggered at that moment in time. Now, what happens in this is you said, systems can actually scale correctly or automatically. We can expand. We live in this world with this elastic nature where everything can be sort of dynamically sized and come across from there. And to be fair to Coinbase, they've done a fantastic job with their front end, through the CDN providers and everything that actually do that. But where they're limited then is the architecture that sits essentially within the back end of this. To transact or to complete their trades, they're going to utilize a blockchain type of environment. They're going to sell Bitcoin, but they're going to develop utilize a blockchain in the back end. Now, blockchain by its very nature is a completely distributed architecture. It's also, it's because of the transactions or what it's doing from a central ledger perspective, it relies on a high level of trust to take place between there, which means that every one of the nodes which is involved in the blockchains, and it can be any number of nodes across from there, have to verify with each other to build this base of trust. And then it's not just as we do between the two peering points, for example, we're going to have to do this between every node that's involved in that blockchain process that goes through this. And this has to take place for the trades that are going on, or the transactions that are occurring. And because of this, and coupled with the distributed architecture you've got from there, and it's incredibly distributed, you don't know where any one of these nodes are going to be within this blockchain environment there. We have the network latency, but also this extra traffic is going to be created for the verification that's not necessarily involved with the trade, and all this exchange of information that goes on. Add all these things up together, and what we get is this, let's just call it a bottleneck, or this performance that we actually can't architect around. Is something outside of their what's what I'm looking for, outside of their control. Yeah. They can actually do from there. So what we saw when was going on this, where this outside the price dropped, and I said the automatic sell positions came in, and people themselves try to get on to sell or to trade their Bitcoin or even buy when it was actually coming towards the bottom there. What they then found was that the transactions themselves couldn't be completed by the Bitcoin. So we got this pushback effect coming into servers, and then the server itself, it wasn't that they necessarily had this many requests coming into the server, although undoubtedly that traffic would have increased. But what it was the south of that, effectively, this, how do we execute on these transactions, which became the bottleneck and the slow process. And unfortunately, there's not a lot they can do about that in terms of architecture. They rely on this blockchain to be able to do these transactions, these trades, and so they're limited by this architecture that goes on. So there's, like I said, there's not a lot they could have done in this situation.
Yeah, it's interesting just how the issue that they experienced very cleanly mapped to this plunge in the value of Bitcoin. I mean, it over a very short period of time, the value fell by 30%. And we see, that just as it started to go down, that's really when we saw like these issues occurring with this service. And to your point, somewhat outside of their control. And, the Bitcoin, there's a level of volatility in it, it's subject to news like this, to, regulation, to even tweets from well-known figures. and that can, it's very unpredictable in terms of knowing when you're going to have sort of a rush on the Coinbase, so to speak, or Bitcoin. So that was pretty interesting, just to kind of see how these external factors had a direct relationship on the service. And, in terms of lessons learned, well, in this case, it's really about understanding that in some cases, even the application provider is not able to, it may just be out of their hands in terms of being able to service all of the requests that might come in around transactions like this. So, just something to keep in mind in terms of, this particular situation in the Bitcoin. So that was an interesting one. We also saw another application outage that happened the day after, and it was similar in some respect from the standpoint of it being application related, not network related. We saw some similar errors throughout the incident. This was Slack, and as we know, Slack is heavily used by many organizations to facilitate, very rapid communication between employees. And this started really during the workday in terms of the US. So it started around 1735 UTC. So it was around 10:35 a.m. Pacific time, 1:35 a.m. 1:35 p.m. Eastern time. So that's kind of really in the thick of the workday, and then continued to have issues throughout. And all of these, again, we see here, these are 500 errors, internal server errors.
Yeah, absolutely. And this makes the service unusable. We come across there. I mean, I got lucky. I was asleep during that process in time. But as you said, organizations live and die on this this communication, this ability to communicate. And when we're seeing these, it was just unusable.
Right. And very similar to Coinbase, if we look at the network path, we don't really see all that much in terms of the availability of the application servers from a network standpoint. So we don't see, any kind of systemic loss across like these network paths. We can see that these nodes are, servers located within Amazon. So these are EC2 instances that are distributed around the globe. So it doesn't look like that Slack is using Amazon's CDN service CloudFront. They're really directing users to specific instances that are hosting, instances of their application, and and they're available. They're up, they're reachable, and of course, very similar to the Coinbase incident, it's also apparent that they're reachable at the application layer because you're getting a response to the server and it's saying that it's just simply not able to fulfill your request.
Exactly, and the other telltale sign, so you said there, is that the network's up, but also the fact this is using all these CDN providers,
Right.
It's impacting everybody. So therefore,
right.
We can reduce the application itself. So.
Right, exactly. A CDN provider in the case of Coinbase, in this case, they just happen to have distributed their own instances across Amazon's network. So, or AWS. So it's, it's not something related to like servers or that are hosted in a particular region. It's not infrastructure related or network related. It's really, the application. So if we just go back up here to kind of get, just an overview, it really did vary, it seemed, depending on the customer and the location of the users. And throughout the incident, it was also something that kind of varied in terms of its impact. And Slack had said that this was due to like a code change or code push that they made. And, because of that, it sort of, affected their customers, but it wasn't, uniform throughout. So in this case, we can see, it just changed throughout the incident. And then, at least in this case, we can see that it came back up about 90 minutes after the start of the incident. So not quite as long as the Coinbase incident, but still, enough to have impacted US users.
Yeah, probably not the same financial impact, but still impact in terms of productivity that went on during that process.
Right.
But
what they it's productivity that was impacted.
Yeah, exactly. Less stressful, but the other thing from this is that Slack said that they had that a code release that went wrong, or there was a problem with the code release from there. That got pushed the wrong area or was actually incorrect when it across there, but they rolled it back. So when you see that recovering, isn't essentially the system recovering itself, it's actually rolled back the code release to actually do it sort of later on.
Yeah, that's interesting. And because of that, we can see, some instances coming back up sooner than others. So, I mean, clearly not something that's optimal, but it seemed like they were able to very quickly correct the situation and get it back up and running, within 90 minutes. So that's all good.
So, an interesting point to that as well, or an interesting point to me, maybe not to others, is that this is all part, like, so they're doing their co-release. So we said this is during the US day. So this is during business hours, where actually impacted there. What we're seeing, and we've all been inundated with these push to the applications to upgrade, upload, improve, or enhance, or whatever it is, do a refresh was the word I was desperately searching for, to do that. So this is like a continuous integration, continuous deployment type of process that goes on from there. What we saw in this methodology then was also then the ability to have some sort of feedback mechanism. We did a release. We've gone through all our tests. What tells me that it didn't work? So, very quickly, as you said, that it wasn't a 4-hour outage. They're able to there because of the feedback mechanism that you see essentially coming from the network, because this is how my users are impacting it and are being impacted. And then we can actually roll back that change or take other sort of remediation or mitigation tactics around it. So, this is everything coming together again. We need to understand that complete journey so that we can understand this whole life cycle, I guess.
Yeah, that's a really good point, because they made this code change during effectively business hours in the US, it appeared. And, while that may seem like that's a risky thing to do, I mean, we don't seem to have a lot of these incidents from Slack, and that seems to be kind of part of their, operational norm to do this, to your point. But because they likely had these processes in place to sort of identify very quickly if issues were occurring as a result of this rollout, they were able to kind of, pull it back. So yeah, that's good to see. and we can kind of chart that out and observe that from these various locations around the globe. So that was a very high-level overview of two application related issues that we saw. Of course, we also have noticed that there's a lot of security incidents that have been taking place recently, and perhaps we'll cover that and have someone on to discuss at a future date. But that's all we have for today. So thank you so much, Mike, for joining us and walking us through these application-related issues. If you subscribe to the podcast, we will provide you a free t-shirt, so please do that. And you can send your t-shirt size and address to internetreport@thousandeyes.com, and we'll get that right over to you. So until next time.